Hello everyone. We finally got to one of the most spectacular topics, liquid animation. Liquid animation is most commonly used in classic animation to animate special effects, splashes, tearings, trails, etc. And logos are no exception. Of course, it looks best in lettering, especially with letters of a round and smooth shape, because liquid trails and drops make them more realistic, emphasizing their essence. But this does not mean that liquid animation can't be applied to more strict objects, as in this Behance and Telegram examples. In this lesson, you will learn how to make such effects and how to use video references from real life. We will talk about the nature of liquid and how to recreate it in animation. We will show you a whole bunch of life hacks that will substantially facilitate your working process and turn difficult tasks into much easier ones. Let's go. For ease of understanding, we have divided liquid animation into two types: elements that enhance animation and elements that change the shape of a logo. The former are trails, splashes, drops, stretches, etc. Simply put, we have a basic animation that is enhanced by liquid effects. When it comes to trails and drops, we are talking about lettering, where they are used most. Sometimes, however, they look great on ordinary logos. Stretches are great for tearings and separating objects. Letters that are stuck together, one object being divided into several, or one object appearing from another. In all of these cases, stretches will surely look great. Liquid animations of the second type are used to change the shape of a logo, thereby defining its dynamics. Liquid effects look great on preloaders, logos with objects filled with liquids, or dynamic looking logos that encourage you to morph them. Like in this example. We have discussed where liquid animation is used. Now let's talk about how it works. A liquid may have different characteristics and be in different physical states. If it is in water, it will be quite fluid, breaking into drops when thinning. But something denser, like honey or tar, will almost always maintain a solid shape. Moreover, their ability to stretch is much higher. So when creating an animation, you should always keep in mind what physical state and properties you want to convey to the viewer. And this is where video references will come in handy. You can find a bunch of footage of pouring water, splashes, and waves in slow motion. This will help you better understand how to animate something like that. To summarize, we need to answer the following questions before animating liquids. What is this fluid? How dense and sticky is it? What effect do you want to convey with your animation? If it is lightness and airiness, bubbles and soaring particles will do. If it is heaviness and saturation, then drops falling under the pull of gravity will be an excellent solution. How detailed and natural do you want the animation to be? With this question, let's move on to the tools. There are two fundamentally different approaches: liquid animation with AE or frame-by-frame animation. Let's analyze the pros and cons of each. And we will start with AE. The main advantage of AE is speed and simplicity. Most of the liquid animations we are going to analyze are pretty fast and easy to make if you know how to do that. The ease of editing is also a plus, for we all know that edits are an integral part of the working process. Another big plus is that you do not have to be a level 80 motion designer to create liquid animations. You just need to learn the basic principles and familiarize yourself with the tools to create them. Of course, without practice you won't get anywhere, but it won't take you hundreds of hours contrary to frame-by-frame animation. There are unfortunately disadvantages as well. Firstly, the limited capacity of tools. Many things are simply impossible to make in AE, and they will never look like a frame-by-frame animation. Of course, you can always animate with path, but this is not the best solution for complex, highly detailed animations. So by animating path, you are actually working on frame-by-frame animation in a tool completely unsuitable for the purpose. And secondly, AE limits you in stylization. Sometimes you can't create particles of the desired shape using effects and plugins. This is especially true for such trails. Now let's discuss obvious things. Why is frame-by-frame animation better? It is beautiful, dramatic, and cool in general. Even a person without any knowledge in animation finds such work especially pleasing to the eye. And of course, frame-by-frame animation provides you with unlimited possibilities. Only your imagination is the limit. You can create anything in any style you want. Any trail, any liquid. You get the point. Well, now let's get to reality. Frame-by-frame animation requires a lot of time to create, sometimes too much. Even with a huge backpack of experience behind your back, you will still have to spend a couple of hours on such animation. Not to mention the fact that at some point you might change your mind and decide to alter some of its parts. This brings us to the second disadvantage: the complexity of editing. Adjusting frame-by-frame animation is another level of torture. Of course, quality frame-by-frame animation requires a honed skill level and years of practice, and you can do nothing about it. If you are not messy in the animation world, just face it and practice. This is the only way to succeed. Okay, the theoretical part is over. Let's proceed to practice to confirm all the statements above. We will move from the simple to the complex. So let's start with the simplest liquid animation that can ever be. Such gluings. Such animations are often used in preloaders, but you can apply them to logos as well. So we have a layer with 4 circles in it. They are animated with scale and position with such graphs to enhance the tearing effect. And now apply the Gaussian blur and levels effects to the entire layer. You have already seen the combination of the effects more than once. Some animators prefer simple choker. It creates a similar effect but provides less control. So we recommend the combination of Gaussian blur and levels. Let's set blurriness high, somewhere around 100. Let's move on to a frame where the circles are close to each other to see the effect in more detail. And let's remove the blur with levels and adjust the size to the original. This is how easily we have created the first liquid animation. The next thing that every animator will eventually face is animation of ripples and pouring liquid. We have prepared such an example, using which we will analyze both cases. Let's start with ripples. Create a rectangular shape the size of the letter U and apply the wave warp effect to it. In Effect Controls, adjust wave height and width and speed. Great. And let's put this layer below the layer with the letters. Next, create a shape on a separate layer. It will be a mask for the wave. Place it above the layer with the wave and apply Alpha Matte. Do not forget to rename the layers so that you can easily find them later. Let's move the wave a little lower and see what we got. Ripples are ready. Adjust the mask a bit. We want the shape to be gradually filled with water and ripples to subside as it gets filled, like when you pour water in real life. For this, let's animate position of the wave layer and the wave height parameter. The whole animation will take about 4 seconds. At the top point, the shape must coincide with the borders of the letter and go beyond them at the bottom. Let's play it. Okay, now easings. We usually pour water pretty fast, and the glass gets filled quite quickly. So the graph for position will look like this. Sharp in the beginning with a smooth fading. The wave height will be approximately the same for some time. So let's move the first keyframe about 1 second forward from the beginning of the layer. Even when all the water has been poured, it takes some time for the ripples to subside. So let's set the second keyframe for the wave height parameter equal to 0, and move it 15 frames forward, relative to the last keyframe. Let's adjust the graphs so that there is a slight slowdown in the beginning when the water is pouring and then a sharp jump followed by a smooth finish. Let's play the animation. Everything is fine here. Let's focus on the flow of water that will fill our shape now. First, let's take a look at a couple of references of a similar process. Check out the beginning of the video. The water flow quickly reaches the glass, and our eyes are almost unable to catch the intermediate states between when there is no water on the screen and when it hits the bottom of the glass. So this moment should last only a couple of frames in the animation. The second point. Water is always mobile, and the flow is not perfectly uniform. And when the flow becomes thinner, it splits into separate drops, and this process is clearly visible. This is a crucial point. Without splitting into droplets, it will not look like water, but like denser liquid, like honey or resin. The last thing I want to draw your attention to is such a droplet that falls into the glass and is immediately buoyed out, bouncing up and falling back, creating small ripples around the place where it falls. Such small details are rather important in animation. They make the animation lively and interesting. Well, let's put all this knowledge into practice. Let's create a water flow with 3D stroke. Draw path on the solid and apply 3D strokes to it. Let's adjust the thickness of the stroke. I will set it to 18 pixels. And move the mask up a bit. Let's make the line a little thinner. Now animating the start. Let's reveal it in a couple of frames. Done. Now move the layers with the waves a bit to synchronize the processes of water pouring and the form filling. First of all, let's change 3D stroke color to green. And now adjust the position of the layer on the timeline so that the shape starts filling right after the line hits the bottom of the letter. Great. Next, let's gradually make the flow thinner as in the reference. For this, animate the thickness overpath parameter in the overpath mode. But first, let's create an adjustment layer and name it Roughen. Now apply roughen edges to it to make 3D strokes more random in shape, and create a kind of gluing of water in the letter and the flow. Move liquid above the adjustment layer so that the effect does not affect it. Let's return to animating the thickness of the stroke. We have already done similar things in lesson 6. By changing the graph of this parameter, we need to achieve the effect of splitting the solid line when it is growing thinner into individual drops. You, of course, can do it with masks or separate layers. But I believe that the method with thickness over path is the easiest and fastest. Here's the thing. The line will split into several parts where we have moved the graph vertices down. You need to gradually move all the vertices down so that the entire flow grows thinner. Moving to the next frame, slightly shift all the vertices to the left to keep the flow moving. Do not forget to make the drops smaller and gradually adjust the graph down to 0. Sometimes this process takes quite a lot of time, but don't be scared. You will do such things faster and better with time. Well, let's move the last frame slightly to the right so that the disappearance is not so sharp. The main animation is ready. Play it. All is well. We'll work on the details. Let's add a buoyed up drop as in the reference. For this, let's create an ellipse and move it below the adjustment layer. Using position, let's animate how it flies out of the water. Increase the drop size a bit. Let's also squash and stretch it by animating scale. Do not forget to squash and stretch in equal proportions. If you squash along the y-axis by 30, you should stretch it by the same value along the x-axis. With the help of speed graphs, let's emphasize the moment when the drop freezes at the top point. Let's check the result. Everything is okay with it flying out. Next, move the keyframes with the drop to the moment when the last drops of water fall. Somewhere like this. Let's play it. No, not quite right still. Trim the layer closer to the beginning of the animation and move another couple of frames forward. This is it now. There is one last thing left. We need to make ripples on water. For the purpose, we will use the effect with a corresponding name, ripple. Apply it to the layer with the upper wave. You should place the center of the effect exactly where the drop falls. Ripples will spread from here. Let's set radius to 2. Change wave height to 10, leaving default width. Set wave speed to 2. Let's see what we got. We still need to make the ripple fade. For this, set a keyframe for wave height. Move a second forward and set it to 0. Set the same keyframe right before the drop lands, so that the ripples begin after the drop falls into the water. And let's play the animation. Let's adjust the last keyframe to make the ripple animation last longer. Everything is fine now. Oh yes, one more thing. We need to change the ripple face parameter to make the ripples begin with the deformation of the water where the drop falls in. That's great. And this is what we got. Great. Let's apply posterized time to the adjustment layer to make the animation look more like a frame-by-frame one. But this is not all. We can improve this animation even more, adding some volume to it. That is, making it more three-dimensional. To do this, duplicate the wave layer and paint the lower wave in a slightly darker color. And adjust the phase parameter of wave warp. So with just a couple of clicks, the animation has become much more three-dimensional and interesting. Wave warp is a useful thing, but it is not always convenient to use it. For instance, when you have a huge number of elements and parts, and it is quite hard to split them into separate layers. And this is the case with this animation. You can make a separate course about how to create such loops, but we will talk about such flasks with bubbles now. We have this flask with liquid and bubbles inside it. Let's analyze how everything is done here. Hide the layer with the waves and bubbles. Create a rectangle. We will make our wave out of it. Apply the zigzag shape modifier to it. It will make the rectangle shape wavy. Size will be equal to 2. Ridges segments to 6. Let's also change the zigzag type to smooth. OK, let's create a mask now and copy the group with the flask for this. Paste it into the layer contents and move it under the rectangle. Combine them into one group and apply Merge Path. With the help of the Intersect mode, the shape of the flask becomes a mask for the wave. But for some reason, both layers have disappeared. Let's switch to the layer with the flask. There are two paths here. One of them is such a line that does not allow Merge Path to work correctly. Just delete it. And now everything is fine. Move the entire group below the layer with the main flask and proceed to animate the ripples. For this, let's open position of the rectangle and set 2 keyframes on second 0 and on second 1. The waveform must be the same in each frame to achieve looped ripples. To make this easier, we will use Snapshot. It allows you to compare the current image on a timeline with the frame that you saved with it. Both frames are the same. Great. Let's add the loop out expression to loop the animation and run the preview. We need to enable the bubbles and everything will be great. There is a small life hack in them as well. As you can see, they move not in a straight line but in a sinusoid. It is quite difficult to create such a sinusoid with the necessary easings inside the shape, for we can't see and change the position trajectories inside the shape group. But we can create this trajectory on a separate layer. Copy its path, and paste it into position of the necessary ellipse, which we will create in the group with the entire animation. The whole layer has shifted a little. Let's return it to where it was. Do not forget that for this you need to select all the keyframes and be on one of them. Let's see. Yeah, you need to flip the group. This can be done using time reversed keyframes. Done. Let's reduce the animation duration to 1 second and adjust the speed graphs. We still need to animate the reveal and disappearance of the bubble. Use scale for this. Let's check the result. Good, but we need to adjust scale a bit more. The bubble should disappear just a couple of frames earlier. And the same thing with the reveal. Let's move it forward a couple of frames. Fine, the animation is ready. The remaining bubbles are made exactly the same way. Let's move on. Now you will find out how else you can use the logo shape to enhance the animation. One of the coolest examples is the NASA logo animation, where the circle shape stretches when a UFO hits it. This is not quite a classic liquid animation, of course, rather an example of jelly-like form. You can create such stretching in several ways, but we will take a look at the simplest and most convenient one, using the CC smear effect. How does it work? Let's open the composition with this logo. We see 3 layers: an already animated 3D stroke trace from the UFO, a layer with stars, and the circle itself. Apply the smear CC effect to the circle. It has only 4 parameters. From is the point from where deformations will start. To is the point towards which everything will be deformed. Reach is responsible for the depth of deformation. and radius determines the size of the area to be deformed. Now let's animate the to parameter to create deformations caused by the UFO in the circle. One frame before the line goes beyond the circle, move the to and from points close to each other, so that the shape stays unchanged. Move one frame forward, and move the to parameter point like this. Next, move on to the timeline, to the frame where the end of the line has completely left this area, and make a small dent in the circle. Select the last two keyframes and apply Easy Ease. Move two more frames forward and paste the keyframe without deformations. Let's play the animation. Okay, let's change the graphs a bit so that the line stays within the circle. Then apply Elastic to add fading oscillations. Let's play it to see the result. Delete the first keyframe. We no longer need it. Next, copy the effect in the Effect Controls panel and animate the next point where the line leaves the circle in the same way. Note that you can apply CC Smear as many times as you want, and each will work separately. As a result, you get cool animation with offsets and bounces. It would be much more difficult to achieve a similar effect by animating path, or using such effects as Liquify. We have animated the entire UFO trail in the circle in the same way, and that is what we've got. The stars, however, are still motionless. Let's fix this. Select all the effects, copy them, and switch to the frame with the first keyframe on the layer. Click on the stars layer and press Ctrl V. The same deformations have been applied to the stars and everything looks as it should. But we can improve this animation even further by applying Turbulence Displace. Let's not make deformations very large. Set amount to about 20, and reduce size to 80. Let's set keyframes on amount and evolution and animate them. For amount, the first and last keyframes will be 0, while 2 in the middle will be 20. In evolution, let's just add 3 clockwise turns. Play the resulting animation. We still have one animation left before we proceed to the part dedicated to animation enhancement elements. You will learn how to make such a dissolving letter. The coolest thing about this animation is that it has a setup of effects that you can apply to almost any object. Closer to the point. We have created a 1000 by 1000 pixel composition and placed a letter in its center. Let's start by creating a mask that will dissolve the letter. Create a solid and apply fractal noise to it. Select the max mode in the settings and increase contrast to about 400. Now let's change the complexity parameter to 1 to get this blurry texture. Let's increase brightness a little. Then switch to the Transform tab and change the value to 80. Great. And now we need to make a loop of the texture moving along a diagonal. Offset turbulence suits this task great. Holding down Alt, click on the stopwatch and write the following expression. Time times 100, negative 200 in square brackets. The brackets are needed since the parameter has two values, not one. The first value is responsible for the horizontal offset, and the second for the vertical one. By changing the sign in front of the number, you can easily change the direction of the animation. Let's animate the texture change by writing another expression into the evolution parameter. Time as well, but with just one value. And let's have a look at the result. Now add this layer to a precompose and name it mask. An important thing, be sure to check the Move All Attributes into the New Composition box when creating precompose. Otherwise, just an empty solid will be added to the composition, while the effect will be applied to the created precompose. OK, switch to the precompose and create another solid and name it particular. After that, apply the particular effect to it. With its help, we will create moving particles that will complement the mask. Go to the Emitter tab right away and decrease the number of particles to 10, and set emitter type to box. Let's also move the position point a little lower. This is the center of the area from where all particles will appear. They are almost invisible at the moment. Let's change their color to black and change their size. All settings responsible for the way the particle looks are in the Particle tab. Let's make the particle size more random. 20 is not enough. Let's set the value to 25. As we need approximately the same movement over the entire area of the mask, we will increase the particle life parameter to 10 seconds. Let's take a look at the animation. We need to scatter particles more. For this, let's increase the emitter size XYZ parameter to 1000. And now, let's set the direction the particles will move along. You can do this in the Physics tab. Switch to Air. What interests us are the Wind X and Wind Y parameters. In fact, these are the same offsets that we have done in Fractal Noise. So set similar values. Play the animation. Not bad, but it can be even better. Particular is quite a powerful tool with a lot of useful features. Let's use one of them and add Turbulence Field. Switch to it and adjust the Effect Position parameter. It defines how much particles stray from their motion path. It adds a little wave-like motion to particles. Let's increase it a bit so that you can better see it. Let's return the value to 50. Just right. Next, duplicate the layer with Particular, but reduce the number of particles and their size to 10. We can't see new particles, as the layers are the same. So let's adjust Random Seed. Now it is great. Finally, let's select both layers with particles and move them to the left on the timeline, so that the animation starts with the map already filled with particles. OK, let's get back to our composition and apply Luma Mate to the layer with the letter. The mask is ready. Now select both layers and precompose them. Name the precompose letter. In the next step, let's create an adjustment layer and apply roughen edges to it. When adjusting it, let's remove the blur and add the liquid effect to the entire animation. Great. Now let's deal with particles that break away from the letter and move with the flow. Create a solid with Particular. Set the particle/sec parameter to about 35, and emitter type to layer. This means that particles will appear from the alpha channel of the layer we specify. To make this type of emitter work, we need to make the mask layer 3D. In our case, it is the layer with the entire animation. And now we can select it in the drop-down list. Particles have appeared, but they move from the center to the perimeter, and we need to set a specific direction for them. But first, let's make them a little bigger and make their size random. No, too big. Move the entire layer below the adjustment layer so that roughen edges applies to the particles as well. Next, go to the Physics tab and adjust the Wind and Turbulence Field parameters, as we have already done earlier, to set the motion path for the particles. Let's check the result. The particles still move too fast. You need to slightly reduce the force of the wind. The last thing is left. Let's make the particles shrink and disappear over time. For this, size over life will come in handy. There is a graph in this parameter, similar to the one we used in 3D stroke. Well, it actually moved from particular to 3D stroke. Having adjusted this graph, we can select a moment when each particle starts shrinking. And this is quite convenient, for you can choose a perfect moment for the particles to disappear. You can clearly see it now. Well, I like this graph. Let's select the layer with particular again and move it to the left on the timeline. And these particles are ready. Select all layers and pre-compose them. The main animation is ready, and we need to duplicate it and paint it in a different color. Purple, for example. Let's make an offset for a couple of frames. Everything is cool, but I don't like the way the bubbles fly one after another even though the letter offset looks great. So we will go the other way. Delete the copy and run TrueComp Duplicator. This is a free script that copies the composition with all the precomposes and solids. The main feature is that each precompose is not just a copy, but a separate composition, and changes in the composition will not affect its copies. Drag and drop the copied composition to the timeline. Change its color. And offset it. Switch to any of the compositions and change random seed in particular so that the particle generation is not the same as in the copy. Go back to the main composition and play the animation. That's a completely different story now. A looped animation is certainly good, but you may probably wonder how we can animate its reveal and disappearance. Quite simple. There are two ways. You already know the first well. It is a reveal with stroke and trim path. The second is more universal, using particular. And now we will analyze the second one. Go to one of the compositions with the letter. Create a solid with particular. Set emitter type to box. Increase the number of particles to 250. Move the position point down here. Now resize the particles and make them more random. Next, let's also redirect the wind in the direction of the animation. Okay, now let's reduce the emitter size so that the particles are closer to each other. Then move the entire layer below the adjustment layer. The number of particles is still not enough as we need them to cover the letter completely, without any gaps. Great. Now let's just make this layer with particular a mask for the letter using Luma Mate. The reveal is ready. You can experiment with the particle size and number during the reveal, or you can speed it up or slow it down by changing the wind characteristics. Now, by changing a couple of settings, I will get a more detailed mask for the reveal. Here you can create an infinite number of alternatives. Take your tasks and the shape of an object you are revealing into account. To make the disappearance, just cut the layer with Ctrl-Shift-D. Duplicate the solid and switch it to the Luma or Alpha Inverted Matte mode. It doesn't matter which one you pick in this case. And here's an important point. You shouldn't cut the solid, but move it from the beginning of the layer, so that the animation begins here. Done. Repeat the operations in the second composition. Here is the animation we get as a result. We still need to add an adjustment layer to which we will apply two effects. Posterize time with a value of 12, which will make the animation look more like a frame-by-frame one, and turbulent displace with the amount and size values of 15 and 20. Let's add the time expression to evolution and run the preview. The whole setup is ready. It is very flexible. By changing the settings for the number of particles, their size, speed, and direction of the wind, you can get completely different results. As an addition to this practice, we offer you the following task. Take this setup and try to recreate such an animation, where there are no holes in the shape, and particles look like droplets flowing from it. Let me remind you that there is a source layer here in this composition, a text layer with the letter which you can replace with any other text or shape to apply the setup to it. As you can see, everything works great. That was the first part of the lesson, in which we have figured out where liquid animations are applied and how they work. In the next lesson, we will talk more about the elements to enhance an animation. Figure out in which cases you can't do without frame-by-frame animation, and in which ones you can imitate it in After Effects. We will back it up with practical examples and learn how to combine various techniques and methods. See you in the next lesson.